Welcome back, and my voice is still not quite there, but I wanted to prove to you one of my favorite theorems in analysis. I was going to put this on homework, but it was so much fun I wanted to do it, and it's called the squeeze theorem. And what it says is that if we have three sequences where one is kind of squeezed in between the others, and if the small one and the big one both go to some limit L, then the middle one has to go to that limit L. And I think this feels very reasonable, right? If you're stuck between two trees like this poor black bear, and both trees are approaching a limit of 5, oh, you don't have much choice. You're going to go to 5 as well. So I'd like to present a proof. Take a couple minutes. It's really nice. So I've got our hypotheses up here. We've got our proof. All these proofs always start with let epsilon be greater than 0. Right? And what do we want to show? We want to show that Bn minus our limit is small in absolute value because we want to show that Bn converges to L. And the very first thing I'm going to notice is that, hey, if I just take this blue inequality up here and I subtract L from everything, well, it doesn't change ordering. Subtracting is fine. So now I've got Bn minus L is between these two other things. And since I know that An converges to L and Cn converges to L, there's got to be some point in time when, Cn minus L is smaller than epsilon. And there's got to be some point in time after which An minus L is going to be smaller than epsilon. And if we just kind of take the later of those 2 points in time, there's definitely going to be some number capital N such that from that point onwards, both these quantities Cn minus L and An minus L in absolute value are going to be less than epsilon. Right? And so we think about what that means. What does it mean for a number to be smaller than epsilon in absolute value? Well, it means those arguments, Cn minus L and An minus L, they both have to be between negative epsilon and epsilon. Right? And so now let's go back up here. We've got these things, An minus L and Cn minus L, and we just finished arguing that for large enough n, those things are going to be between epsilon and minus epsilon. So let's throw that in here. So great. Now, well, let's ignore the middle stuff. This means that Bn minus L has to now be between minus epsilon and epsilon. And what do you know? That's the same as requiring that that the absolute value of Bn minus L is going to be smaller than epsilon. So once again, and as we have done with many proofs, we've started with an epsilon greater than 0. We've found a capital N such that for every n greater than that, we've shown that the distance between Bn and this limit is smaller than epsilon. So therefore, we've proven that this limit really is what we said it is. So that's it. One more look at the black bear, and have a great day. Bye.